me today. Two second grade assistants, Ian and Oliver, are going to help me out with a three-dimensional shape lesson. So in your math lessons in Nearpod, you've been studying two-dimensional shapes. Shapes that have length and width. Shapes that lay flat. Today we're going to look at some three-dimensional shapes. And what I have laying in front of Oliver and Ian right now are what are called the nets of three-dimensional shape. And a net is when you open up a three-dimensional shape and make it flat. And the first three-dimensional shape we're going to look at is a cube. If you have a cube in your house, press pause and find it now. You can do this along with us with a shape like a dice or a square cube box. Okay, Ian, will you hold up the net for a cube? Okay, this is the net for a cube, and what I see is 1, 2, 3, 4 squares down the middle. It looks like one big long rectangle, and then 2 squares off to the side. Ian, will you take that net and form it into a cube for us? Thank you, Oliver, for handing him the box to put his cube in. Now we're going to count the faces on this cube. So I think of a dice, and if I think of a regular dice is going to have
6.
1, start on the front, 2, 3, 4 faces, 1 on top, 1 on bottom, 5, 6 faces. Or a dice is going to have 1, 2, 3, 4, 5, 6. So I think of the faces and I think of 6 faces. Now when I count the edges, some second graders think of flat surfaces. And when they think of a flat square, they know it has 4 sides or 4 edges. And then they know it has 4 angles or 4 corners. So they think it has the same number of sides and angles. But when you go to three-dimensional shapes, they do not have the same number of faces, edges, and vertices.
This one has like
So when I count the edges,
I think it has 12.
I have to hold my cube and I have to count. Do this with me if you have your cube. 1, 2, 3, 4 edges on top. So if I have 4 edges on top, now we have to count the 4 edges on bottom.
So that's
5,
8.
6, 7, 8. But I'm not done yet.
Then plus 2.
See, I have to count the edges that go from the top to the bottom. So I was at 8. Now I have 9, 10, 11, 12. And I have to count 12 edges on my cube. Now if you have your cube or your dice in front of you, try to count those vertices. Vertices are the points where 2 edges meet. I have 1, 2, 3, 4 on top, and 1, 2, 3, 4 on bottom, 4 on top, 4 on bottom, and I have 8 vertices. Oliver, will you hold up the rectangular prism net?
I guess it's this one.
Hold it up for us flat, Oliver. And what I see is 1, 2, 3, 4 rectangles down the middle, and then a rectangle or square on either end. A prism is any shape that has 2 sides where both faces are the same shape. This shape has a rectangle as the 2 faces on opposite sides. Oliver, can you turn that into a rectangular prism?
This looks like one of the, if you put it flat out, this looks like one of the persons that Will used to draw. He always used to draw them like blocky, like.
Oh, like a robot person.
Yeah, I remember that. I remember he always drew people like that. And so
Yeah.
did Ian. He still does that.
Well, so if I look at my rectangular prism, I can think of a cereal box. If you have a cereal box or a rectangular box in your house, stop, press pause, and grab it. You can count the faces, edges, and vertices with us. Boxes for games count as rectangular prisms too. Things like your Monopoly box or your Yahtzee box. All right, you ready, Oliver? Okay, let's count our faces first. Here we go. Ooh, that's okay. 1, 2, around the back, 3, 4. Don't forget the top and the bottom, 5, 6. So the rectangular prism has 6 faces.
They have the exact same thing on both.
Oh my gosh.
Square and
Now wait a minute. A rectangular prism is going to have 1, 2, 3, 4 edges on top. 1, 2, 3, 4 edges on bottom. But don't forget, we have to go from the top to the bottom. 1, 2, 3, 4 edges down the side. 4 plus 4 plus 4 is going to make it have 12 edges.
I told you.
Let's count those vertices and see if you're right. If you have a box in your house, count the vertices with me. 1, 2, 3, 4, 5, 6, 7, 8. And it has 8 vertices. So, now wait a minute, if the cube and the rectangular prism are the same, then Ian, does that mean the triangular prism is going to be the same?
Maybe.
Okay, well let's find it and see. Ian, find the triangular prism and hold up the net for a triangular prism. So I see triangular prism, 1, 2, 3 squares, and 2 triangles. A prism is any shape that has 2 opposite sides that are the same shape. If these were hexagons, it would be a hexagonal prism. If these 2 were pentagons, it would be a pentagonal prism. Since they're triangles, we have a triangular prism. Now let's count the faces on my triangular prism, and let's see if it has the same number of faces as the rectangular prism in the cube. If you can find a triangular prism in your house, grab it and count with me. But this one might be a tougher shape to find. Here we go. I'm going to count 1, 2, 3 flat faces. That's around the edges of my triangle. But I can't forget the front and the back. So I have 4, 5. How many faces do I end up having? 5. Now let's count those edges. See if the edges are the same as a rectangular prism in this cube. So I have a triangle, so I'm going to have 1, 2, 3 on the front, and then I'm going to have those same 3 on the back. 1, 2, 3. 3 and 3 is 6. But I can't forget I'm going to have my top, my side, my bottom. So I have 3 plus 3 plus 3, or 9. I have 9 edges. It is not the same. And now look at the vertices. If you can find one, count the vertices with me. 1, 2, 3, 4, 5, 6. This has 6 vertices. Is there any way to memorize all of these numbers?
No.
No. You don't need to memorize these numbers. Instead, you need to picture how you could count the front and the back, the part you can't see, the top and the bottom. Okay, Oliver, you're up. Can you find the net for the cylinder? Now this is a tricky one, Oliver. Hold this up so they can see that what it has is 1 rectangle and 2 circles.
Yeah.
A cylinder has 2 circles on either side. Oliver, turn that net into a circle. And let's count our flat faces, or into a cylinder. Here we go. Put it in there. Anytime I see 2 circles on a flat net, I know that's going to fold into a cylinder. In your house, a cylinder is going to be a can of corn or green beans, or a can of soup. If you have a can in your house, press pause and find it. You can count with us. Okay, Oliver, the faces are going to be the flat faces. So on a cylinder, it's going to be the top and the bottom.
And there's 0 vertices and 0 edges.
So I'm going to come over here and say there's 2 faces. See this edge around the middle? It's not a flat face. It will roll very nicely to you, but it's not flat. Now, edges have to be straight edges. The edge around the top is not straight. The edge around the bottom is not straight. So this has 0 edges. Vertices are where edges meet. So if there's no edges, there's no vertices. So a cylinder is 2 faces, 0 edges. Ian, can you find us a cone? If you have an ice cream cone or a funnel in your house, find those now. Ian, anytime I see a shape that has like a half a circle and 1 circle, I know that net is going to fold into a cone. Ian, how many faces are going to be on our cone? You need to hold it up here so that your friends can see it.
1.
Okay. Well, around the outside of my cone is rounded, so that's not a flat face. So only this is a flat face. So a cone has 1 face. What about edges? Well, has 1, no edges, because this edge isn't straight. And what did I say? A vertice is where an edge meets. Now there is some argument that this point could be called a vertice. But actually, if there's no straight edge, it's not considered a vertice, even though a cone has a point. So this is 0 vertices because there are 0 edges on a cone. Our last shape today is a pyramid. A pyramid, Oliver, does come to a point. It's made up of what, Oliver?
Triangle.
How many triangles make this up?
4.
So it looks a lot like 1, 2, 3, 4, like a triangle.
Yeah.
But when all of those triangles fold together, I am left with a pyramid. Now, pyramid and prism both start with P, but they are not the same. A pyramid has one shape on the bottom, in this case a triangle, but you could have a square pyramid. And one point on the top. Let's count our faces around our pyramid, Oliver. 1 on the bottom, 2.
3, 4.
Okay, so here we go. 1, 2, 3 around the edges, and 1 on the bottom. 4 faces. Let's count our edges. Oliver, count our edges with me, please. 1, 2, 3. So count them going down. 1, 2, 3 first. Now count along the bottom. 4, 5, 6. So this has 6 edges. Now let's count the vertices. Ready? Oliver, count our vertices. Start at the top. 1, 2, 3, 4. So this has 4 vertices. If you can find a pyramid in your house, try to count. But keep in mind, a pyramid could have a triangular base or it could have a square base. They would have a different number of faces. That's it for today.